There is a benchmark called SLOG that tests compositional generalization. It checks whether a model can recombine what it learned into brand new structures. 17 test categories, 1,000 samples each. The previous champion, AM parser, used a representation that was deliberately blind to word order direction. Its operations could not tell left from right. One researcher swapped in an old idea from linguistics, CCG-directed types, where a slash says exactly which side an argument sits on. Same encoder, same parser backbone, swap the representation. And the results split perfectly down the middle. It won on every category that tests position. And it lost on every category that does not. Here's what actually changed. AM parser tags words with an AM algebra. Its apply and modify operations are directionless, built for graph tasks where linear order does not matter. Combinatory categorial grammar is the opposite. A category like S\NP means the verb needs a noun phrase on its left to become a sentence. The slash direction encodes which side of the head an argument appears on. Direction is not a knob you tune in, CCG. It is the definition of how the pieces combine. The system keeps a frozen BERT encoder, a single linear decoder of just 30,000 parameters over 26 CCG types, and a deterministic CKY parser that composes the category symbolically. 8 minutes to train on one GPU, no validation-based model selection. SLOG sorts its 17 categories into 4 groups by what structural move they demand. Recursive depth stacks the same rule deeper and deeper. Modifier position shifts where an adjective or clause attaches. Extraction position pulls a phrase out. And one questions vary where the question word lands. The prediction is sharp. If directionality is doing the work, the gains should land precisely on the categories that test position shifts and vanish on recursive depth, which is direction agnostic. This is the whole test. A pattern that aligns with the direction-relevant dimension and not the others. There is a catch built right into the method. Directionality cannot be isolated as a knob you switch off, because removing it dissolves CCG as a formalism. So the paper cannot run a clean ablation. Instead, it runs what it calls a pattern alignment test. It checks whether the deltas line up with the dimension direction should affect. That is reasonable, and the authors say so plainly. But it is correlational. Other differences, decoder architecture, training recipe, tight granularity, could in principle produce the same non-uniform pattern. Directionality is the most parsimonious explanation, not a proven cause. On the 5 position shift categories, the directed system beats AM parser on all 5 by an average of 29.9 points. 2 of those categories are ones AM parser scores exactly 0 on, outright dead ends. On the what question subcategories, the ones where direction matters most, it swings between 30 and 67 points. The direction-aware representation fixes precisely the failures you would expect it to fix. Gains land where the prediction said they would. Finding 2 is the mirror image, and it is the honest part of the story. On the 6 recursive depth categories, the directed system loses to AM parser on all 6 by an average of 31.9 points. On 2 deep recursion categories, it collapses to near random 18 and 17%, while AM parser nails them at 100. Directionality helps exactly where predicted and hurts exactly where it should not matter. Symmetric, elegant, and a real cost. Think of it as arrows. The directionless algebra connects its nodes without saying which way they point, a tangle that cannot distinguish left from right. Add direction, and every edge gets an arrow, left argument, right argument, ordered and unambiguous. The structure that was hidden in the tangle becomes readable. That readability is what fixes position shifts, and its absence is what costs you on deep recursion, where order matters less and the rigid arrows just get in the way. Now the honest scope, because the headline overstates this. First, the overall gap is 5 points smaller than the system's own seed noise, so the word surpass is not statistically meaningful. Second, that 29.9 position average is carried by a single category that jumps from 0 to 97. Drop it, and the average halves. Third, the 90.7 state-of-the-art uses a 400 million parameter encoder that AM parser was never run with, so that gap conflates directionality with sheer scale. And at that top, config the system actually loses 1 position category. The directional pattern is real and clean, the champion claim is not. Swap a directionless representation for a directed one, and the gains fall exactly on the categories that test position, the losses exactly on the ones that do not. Directionality's role is real. The clean win is the pattern, not the crown. Subscribe for the next paper breakdown.